Question 4. Statistical models can provide a cheap and quick way to describe a real-world situation. Give 2 other reasons why statistical models are used. So if you think about the last question, not the last question, the one before, which was about the distance you are from a train station and how that might affect the price per square metre of a house, if you'd formed a regression equation which said how those 2 variables were linked, that would be a statistical model. So what has that done? Well, it's not just that it's cheap and quick, or to build on that it being quick. We could say that it simplifies real-world problems. It makes them easier to understand. So we could start by saying statistical models help to simplify real-world situations. You want to try to use the different words that they use. So they use cheap and quick. So we're going to use simplify real-world situations to make them easier to understand. Because of course there would be many things that affected price per square metre, but we could try to narrow it down to some of the key important facts in our models. And what else? When we've got a model, we can use it to make predictions. So that's another second useful thing. Or rather than just saying make predictions, you could talk more about that you could analyse situations using the model, for example. But this would be enough for 2 marks. Okay. Then it says, a scientist wants to develop a model to describe the relationship between the average daily temperature and her household's daily energy consumption in winter. So the temperature, X, that's the thing that is independent, that varies, that she can't control, and her household's daily energy consumption reacts to that, and it's Y, the dependent variable. And it says that this is happening in winter. Pay attention to all the details because they might be relevant later. A random sample of the average daily temperature and her household's daily energy consumption are taken from 10 winter days and shown in the table. So here we have. Now you've been given some figures to use, some calculated parts, and you're told to find S, X, Y for these data. So you're going to need to look at your formula book. And your formula book will tell you, so we're on part B now, that S, X, Y can be calculated by using the sum of X, Y and minusing the sum of X multiplied with the sum of Y divided by N. So now we can look at what of these figures we've been given and which ones we might need to calculate. So sum of XY we've got, that's been given here, 283.8. Sum of X we don't have, so we would have to work it out. So that would be adding all these X values together. Now let's just see what they're going to go on to ask us. Find the regression line. Give an interpretation of the value of A. Estimate. Okay, there's nothing there that suggests to me, because we don't have to calculate R, I don't think it would be worth typing all of that into the calculator. So I'm just going to find the sum of X by adding together the X values. So starting from negative 0.4, adding on negative 0.2, and so on until we get to the end, adding on 2.5 and then 2.6. So let's do that now. So that's negative 0.4. We'll end up subtracting 0.2, adding on 0.3, 0.8, 1.1, 1.4, 1.8, 2.1, 2.5 and 2.6, so that's making 12. So for our sum of x, we're going to use 12, and we're going to multiply that with the sum of y, which we've been given as 255, and we're going to divide that by n, which is how many pieces of data, and you can see that there's 10 sets of data, but it also says that 10 winter days have been used. And now we need to put that into the calculator. 283.8 minus 12 times 255 over 10. And that gives us negative 22.2. Part B says, find the equation of the regression line of y on x in the form y equals a plus bx. That's what we've got to work out. And a and b need to be given to 3 significant figures, so they're telling us how accurately to work. Now, in your formula book, it will tell you that you can find b by doing sxy divided by sxx. Now, we've just worked out what sxy is, and in the question, they do tell us what sxx is. So now we can take sxy, negative 22.2, and divide it by sxx, which is 10.36, to get a value of b. So that's negative 22.2 divided by 10.36. Now, this is quite a long number with recurring dots here and here. So let's keep the accurate one in our calculator because we're going to need it in a second, but we will record this to 3 significant figures for use in our final answer. And now that we found b, we need to go on to find a, and it tells you again in the formula book that a is given by y bar minus b x bar. So y bar is the average value of y, which will be the sum of y's divided by how many there were, minus b, where we're going to use minus 2.142, blah, blah, blah. We're going to use the fully accurate one, multiplied with x, which is going to be the sum of x divided by n. Now we can put the rest of the numbers in. So sum of y in the question is 255, and we're dividing by 10. Then we've got our negative number from our calculator, multiplying with the sum of x, which we worked out was 12, divided by n, which is 10. And now we're going to use that to figure out what a is. So onto my calculator, I need the fraction 255 over 10. Then I need to subtract, and I need the b value, so I'm using the answer button so that I don't lose accuracy, multiplied by 12 over 10. Let's check that that's all right. Okay, and that gets me 28.071428.5 and so on. That's the fully accurate one, and that's 28.1 to 3 significant figures. And now I can take those values for a and b and put them back into here, giving me y equals, and for a, 28.1 plus, actually we don't need the plus because we're adding on a negative value for b, so we will just put minus here, 2.14x. And that's it for part C. Part D says give an interpretation of your value for a, this number. So remember that y, it says in the question that y is the household's daily energy consumption. So this is calculating you y values, and in particular 28.1 is the y value you get when you substitute in x as 0, and x, it says in the question, is the average daily temperature. So what we're saying is 28.1 and the unit is kilowatts hours, is the expected daily temperature, is the expected daily energy consumption on a day when the average daily temperature is 0 degrees. And of course, temperatures can go below or above 0 degrees, but when the temperature is 0 degrees on average on a day, X would be 0, this would become 0, and so Y, which is the energy consumption measure, would come out at 28.1. Part E says, estimate her household's daily energy consumption when the average daily temperature is 2 degrees C. So for this, all we're doing is taking X from 0 up to 2, and Y can be found by doing 28.1 minus 2.14 multiplied with 2. Now, we were specifically told to write this formula to 3 significant figures, so at this stage I wouldn't be using anything more accurate than this. And I get 23.82, which is 23.8 to 3 significant figures. Considering the calculation is only accurate to 3 significant figures, you wouldn't really be able to give an answer more accurate than that, and that's measured in kilowatt hours. The scientist wants to use the linear regression model to predict her household's energy consumption in the summer. And part F says, discuss the reliability of using this model to predict her household's energy consumption in the summer, and it's worth 2 marks. So to score the 2 marks here, you need to explain that the scientist's model will not be reliable in the summer as the summer temperatures will differ greatly from the winter ones that the model is based on.